Hi guys, welcome to TechoGenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello everyone, welcome to the TechoGenius Academy. Today we are here to discuss about the next session on Linux system programming. So we discuss about the inter-process communication in our earlier videos. We discuss about the thread management and the some of the part of in the file management and in the IPC. So in the inter-process communication we discuss about the different methods, like we discuss about the pipe, named pipe, which is FIFO, also message queues and the shared memory. So today I just want to deep dive into the message queues. So what are the different functions which we have used in the message queues? So yeah, so simply as we already know that message queue will allow the process to exchange the data in the form of messages, but we need to keep in mind that message queue is the slowest IPC, because in this when the two process has to communicate in the message queues, kernel make a linked list and send the data to the kernel, and kernel has to do a lot of work. Then that's why it's a slowest IPC. So we use shared memory on top of that, which is the fastest IPC mechanism. So in this message queues, earlier in the earlier video we discussed about different functions. We discussed about the message get, message send and message receive, where we have written two programs where from one file, from one process, we are getting and creating, just opening the message queue, and we are sending the message queue over the we are just sending the message over the message queue, and from the other end, like from the other process, we are opening the same message queue with that whatever the ID we got it from the message get, and we are receiving in the received end, like while you like we are used message receive over there. Now I just need I am just more curious to share like how we can use this message CTL function. So in my earlier video, like whatever I discussed, if you are not aware of these things, please go and check out my earlier video, then you can have a better idea, then you can search on this. So message CTL is like it is useful for doing some control operations on message queues. Okay, so it's confusing. So what is the meaning of control operations? So suppose like there are so many message queues. So if you want to control those operations, few operations on that message queue, so how you can do that? So this is that few this is the function call, so message CTL. And okay, so today in I will just write some example where I will just create the message queues. Like we can write some like a message send and message receive to process, and we can communicate and all. And how we can see that the command to display the messages is ipcs-q, and for deleting the message queue is like the command ipcrm-q id. But if we don't want to do it from the bash shell, if we want to use some calls or some flags, or how we can do that? So is there any mechanism where we can where in some big project, suppose there are different message queues are there, like from one end it is receiving some messages, from other end it is receiving messages, they are comparing and they are doing their stuff and going further. Then in the later stage, if you want to delete those messages, that delete those message queue when the memory is full or something like that, then how you can do that stuff? so you can't go to because it's on the running stage, so you can't go back and do that stuff. So using in the code only, how you can do that. So msgctl is the function which is useful for doing this such operations. So first of all, what I will do, I'll just go to the terminal and I'll try to create some message queues, some message queues, and we will see that these message queues are created by using ipcs-q, and then over that we will just write some other program where we will use msgctl call just to remove those message queues. Okay, so first of all, just let me go to the terminal. Yeah, okay, yeah. Let me just quickly create one directory here. You can say IPC Linux system programming. Okay, so we can say LSP, and here we can just create IPC, and here we can say advanced message queues. Okay, so we can go here, and probably what we can do here, we can just simply create the message queues, and for that I just need to create one file. Okay, so before that I'll just check if there is any message queue in the list. Okay, so there is no message queue. Okay, so this program is basically for creating the message queues. Let me just quickly include the header files. So these are the header files which we will use here. Now let me just quickly write the main function. So the first thing I just need to use here is how many message queues we want. So let me just take one variable here, and I'll just rotate up to some 25, some number. Okay, so here I want to use message get. What I need to use here, I mean I can say from 0. Okay, so from 0 I want to use. Okay, so I can use I here. Okay, let me just call it like from 1. Okay, IPC create. These are the permission, like it will create. Okay, and this will return some ID. So I'll just ID here. Okay, this will be the message ID. Okay, and if you want to print also, ID. So this looks good. So I'm just creating and opening the message queue, and it will return the ID, and I'm just printing that ID, nothing else. So let me just quickly do that. Okay, so these many message queues are created. So for the confirmation, let me just go and quickly check. Yes, this is correct. So we got that. So these many message queues are created. So now if I want to delete that, how I will do that? IPCS -q is for displaying, and IPCRM -q, and that ID, message queue ID, we need to do, and one by one we can remove that, correct? But now we need to use some mechanism, and we need to use some functions which is already present in the message queue, so to delete that. So how we can delete that? So that one is our next target, and to do that, let me just create one file, and one by one we will just check what are the calls and how to use that calls. So let me just go to the man page. Yeah, so msgctl. So msgctl perform the control operation specified by the command. So whatever the cmd will be there, and there will be the parameters will be the message queue ID. Okay, and the structure msqid_ds. This is the data structure, and this data structure will have few of the parameters. Okay, these are the parameters are there. Okay, so these are the parameters involved. What are the time of last message sent, what is the time of last message receive, and all, and few of the flags are also there, like some of the values like IPC stat. So valid values for the CMD are, so it depends on the CMD, as it is mentioned in the as a second argument. So message CTL perform the control operation specified by the CMD. So we need to be very careful what we are using here. So as it is there, like IPC stat will be there, IPC set, IPC RMID, IPC info, message stat. So these are the thing we will use for. So like message info, so it will return the message info info structure containing the same information as IPC info. So whatever the information about that message queue information, it will return that, and message stat, it will return a message queue DS structure for IPC stat. So similarly for IPC info is there, IPC RMID. So IPC RMD, what this is command will do, this will immediately remove the message queue, awaking all waiting reader and writing writer process. So this probably we need to use, or probably we'll check like how we can write that. And okay, there will be one structure here. So IPC info, So this probably we need to use this structure of type message info. Okay, and this will give the maximum number of entries in the message map within the kernel, maximum number of bytes that can be written in the single message. So about that size and whatever the different parameters available in the message queue, so it will give us all the information about that, like whatever the message segment size unused within the kernel. So what is the maximum number of messages on all the queues in the system. So whatever the message queues we are using, so how many messages are there, as you can see here, ipcs-q. So these are the zeros are there. So if any message we will send, suppose from one process message send, we are sending hi, or whatever the we can say the RTC time, or in the real-time project, so we will send the temperature value or something like that over the message queue to that other process. So in this all the listing will be there. So what message info structure will do, it will give you the information that how many messages are present over the message queue. So these structures are helpful for that. Okay, so there are so many things are there. So parallelly, like we'll start one by one. So and probably we'll come back to this page to catch up few stuff. So let me just quickly create one file, delete all message queues.c. let me just quickly include the header files. Before that, I'm just writing this, deleting all the message queues from the message queues, okay, from the list. Okay, this one is pretty much good. Let me just quickly include the header files. Okay, if anything I missed, I will just quickly, I'll just 1 second, okay, so these are the stuff. Okay, so the next step is we need to use the msgctl operations. First we will get all the information about the message queue to our local buffer, and after that we will just go and try to iterate a loop where we will get all these IDs which is that already created message queues ID, and we'll get that, and over there we will use the msgctl call to remove the particular message queue. So first of all, we will get all the size of the kernel entries array, and to do that we will use msgctl. Let me just quickly write the main function for that. So we need to use the entries. So we'll use, so whatever the size of the kernel entries and whatever the message information about that, we will get it over here using msgctl. So let me use as a maximum index. Okay, so this is the max index equals to msgctl. Okay, and probably we need to pass 0 here. Okay, and what we need to use here is the message info. Let me just return the, okay, it will return a message info structure containing the same information for that IPC info, except that the following fields are returned with information about system resource consumed by the message queue. The message pool field returns the number of message queue that currently exist on the system. Okay, so this message pool will give you the information. Okay, so it will return the message info structure. Okay, so probably we need to write that message info structure also, and we need to pass that structure. So from here in the local buffer we need to pass that. So what I need to do here is I need to pass here, that command is message info okay, and here we need to pass the message info structure. So to do that we need to create here, like we just need to declare here message info, and we can just write the same name, and we need to typecast. So structure msqid underscore ds we need to use. So struct underscore ds message info. This will return all the message queue present in that system. Okay, great. This one is good. Till now here it's everything is good. So now we got that index. So how many values are present? So let me just print the number of active message queues. Present. Okay. Okay. Now we got so here we got all that active message queue in the list in the maximum index. So whatever the information we got from the message info structure. So now the next thing, we need to retrieve all the message queue IDs. So how we can do that? So for that we just need to take one variable here. I'll just take it as I. For I equals to 0, I less than equals to maximum index value. Okay, and to get that, what we need to use here, So let me just quickly go to msgctl and let me just check the cmd command. Okay, so what is this message stat? So what it will do, it will return the message queue ds structure for the IPC stat. However, the message queue ID requirement is not a queue identifier, but instead of index in the kernel internal array that maintains information about all the message queues in the system. So the message stat will give us the information about that message queue IDs in that list. So message ds structure, so this is the message ds structure. So whatever that IDs are present in that, and we need to use this. So how we can write that? Let me just so I need to write one structure here. Declare struct msq id underscore ds, that is the data structure only, and same I will use here. Okay, and to get this I will just write here message queue ID, we need to get it. So mess queue ID equals to message ctl, whatever the I value is there. Okay, and message stat and the buffer structure. Okay, so that structure, that variable we need to pass here. Okay, and after that we need to, what we need to use here, you can just simply write here if message queue ID is less than 0. So in that max index here also you can write the error message. Okay, so check for any error condition. Okay, similarly like here also I'll just write it for your reference. P error message will write the correct error message. Okay, so now what we need to do, we need to remove that ID. So we got that ID. What we need to do, when we will get the ID, we need to remove that. So how we can remove that? So that cmd command which we were talking about is that IPC RMID. It will remove the message queue. Okay, awaking all waiting readers and writing process. Okay, so we will go here and we will say here if message ctl and whatever the message queue ID we got, just remove that and if is there any error or if this fails, just display the message on the screen. I think this is pretty much good. So if all these operations is like all these operations are successful, then probably we can say that all the message queues in the system are removed, or we can say deleted. Great. So you know that whatever the structure what we used and all, so probably we will just run this. What is the x-axis? Type.h. Okay, this is types maybe. Okay, let me just clear this. Okay, okay. Number of active messages queues present in this are 23, and all the message queues in the system are removed. Then now I will just run ipcs-q. Now see, we got successfully covered this, like how we can delete all the message queue from the list using the msgctl call. So in this way it will help you to understand more about this msgctl function. So just try that out. So there are so many different command is also there. So what are these parameters and all, just try to print the values and all, and just try to play around these calls and all. So what we have used here, we used it ipcrmid, we used message info, message stat, and ipc info we have also used. So just try to use all these commands and all, and try to do deep dive into this. So probably in the next session we will cover probably I just want to cover the shared memory and the semaphore concept. So that concept was we were discussing about that, how we can write and how we can send, or how we can get the messages over the shared memory. So but like if we want to use exchange the message over the shared memory, and we need to use the semaphore also to have the synchronize between the two processes. So how we can do that? So probably in the next session we will do that. So for now you need to try more examples and more sample application, which will definitely, these operations will definitely used in your future projects and all. So try practicing and all, and please don't forget to like, share and subscribe to the channel. So please like to the channel, so how much you will like that much time others can also see on the channel and all. So it will help others to grow also. So thank you so